I wanted to do this document. This is something I always did with kids, like towards the end, to kind of put some stuff together and to see if they really had it. And I actually put a problem like this on my test, so I wanted to kind of at least give them a heads up, just to kind of give them some thinking that they may not have had. So the first problem puts all of the symbolization and makes them have to put words with everything. And so notice that in this problem, they have to know what it means if you go to a number and you get an infinity answer, what is there? And if you go to infinity and you get a number answer, what does that mean? So they kind of have to put this all together. The first thing that I would probably do, actually, is to show them that plotting their points is probably the thing they need to do first, and then go back and do the limit parts. So if you have a y-intercept at 0, 5, there's 0, 5, and then the only roots, that means you cannot cross the x-axis again, is going to happen at -1, 0. I'm going to change the color of my pen. I think I like red. I think that would show up a little better. There we go. I'm going to go back to that. And then at -5, -5 is right there, 0. And then there's a point at 1, 2, 3, 1, 2. This point at 3, 2. So I cannot cross the x-axis again, and I have my y-intercept. This is a function, so I cannot cross over it again either. So the thing I want to think about is, so if there is, let me think about this. What does that mean? If you go to a number and you get an infinity answer, there's a vertical asymptote at that x value. So at -3, I'm going to draw a dotted, dashed, line to indicate that there is an asymptote. And as I come in from the left, I must be going up forever, and they have to do that. Coming from the left, I have to go up for, don't run into it. This is really hard on my Mobi. I have to go up forever, right? And coming in from the right, I have to be going down forever. Now notice that I'm going to go to the closest point that I have defined and just do that. Go down forever. And maybe, I'm going to do that. Maybe I should make that a different color. Make my dash line a little bit different color. So make that green. Make it a little bit easier to discern. Here we go. That was not looking very good, so I thought I'd try that again. All right, let me go back to red. Now, so go up forever, not touching it. Arrow indicating up forever. There we go. And then going down forever. Notice I chose the closest point to the vertical asymptote and went from there. This means that as I go left, forever, I have to write a y of 0. So I'm going to chill at y equals 0. So left is over here. So notice that I'm actually going to hit 0. You can hit a horizontal asymptote. So you can do one of two things. You can either cross it and come back up and write it, or you can bounce and come back down to it. Either one is the correct answer. Let me say that again. You have to hit 0. So you're either going to cross it and come back up to it, or you're going to bounce right here. You're going to bounce and come up and come back down to it. So either one of those is correct. So there's not one correct answer. There's several. In this one, on this side, you have to go right forever and go up forever. So there's a lot of things you can do, but you have to make sure that you hit that graph. You've got to hit that function. So I cannot, the only thing I can't do is go below the axis. I can't go down and go back up. So I'm just going to do the easiest thing and go here and then go back up forever. So that is a sample, and I'm going to clean this up. Thank goodness I have a pencil. All right. There we go. That looks better to me. So that is an example of what you could do. A lot of teachers don't like this because there's lots of different answers, but you get to see the creativity of kids and see if they know what they're doing. And so notice that when I walked you through this, I said, let's do the easiest part first and then interpret what the limits mean, and that's a nice way to show kids how to do that. Let's look at the problems on the bottom and talk about these. Piecewise are really, really hard for kids, and so I like to talk about this. This is what is happening on this piecewise function. Well, you have a parabola, that's a parabola, and someone has just plucked out a point. That's all they've done. So someone has graphed a parabola that opens up, and at 1, they just said, okay, that's not a point anymore. And then they went and put this point somewhere. In this case, if you put 1 in there, it would be 6. So they just went and put a random point like way down here. That's what they did. So what this is doing when they say x not equal to 1 is they're actually just taking a 1 point out, and then this piece is putting that point somewhere else. It could put it right back where it belongs. If you put 1 in, you get 6. So you know that does not match. So they're just putting this random point somewhere else. So that is what's happening in the piecewise function. A lot of people do not know what this means, and that's real important to talk about. In this case, you are actually removing where the asymptote is. So you have like 1 over x minus 3, which is like that. And so it normally looks like this. 1 over x minus 3 looks like this. And so what you're doing is you're removing the asymptote part like that. Yeah. Drop the graph. And you're putting 3, 5. So you're putting a random point where the asymptote is. But does that make it continuous? No. So you're putting a point where the infinite discontinuity would be, but it still makes it not continuous. In this case, this is a hole where you put that. And when you factor x plus 3, x minus 3 over x plus 3, and see, negative 3 would make this 0 over 0, right? You factor, cancel, plug back in. You would get negative 6. So you would end up graphing the line x minus 3, so something like that. And at negative 3, there's this hole at negative 6. And there's this random point at negative 3, 7. Again, still not making that continuous. So this is talking about, you know, can we plug in the hole? And no, we didn't. This is putting a random point on where the asymptote would be, still not making it continuous. This is taking out a point and not plugging it back in and making it not continuous. So all 3 things are not continuous, but they're for different reasons. And the last little thing we want to talk about is, and I put this question on the test, and we hadn't talked about kind of interpreting this as much, so I want to make sure I talked about it. So it says, for the given table of values, what limit situation does it simulate? So where are your x's going? Your x's are going to 3, and from which direction? From the left, and this is f of x. And what are your y values doing? They're getting larger, so they're going to positive infinity. So taking a table like this and interpreting what it means is kind of what we wanted to do there. So as x goes to 3 from the left, the y values are getting larger, so it's positive infinity. This is kind of very different. It's a different way to think, but I wanted you to see it, because what I'm actually going to do is tell kids, hey, this problem is wrong. What is wrong with it? And if they can tell me what's wrong, then they really know what they're doing. So I wanted to kind of go through this with you. All right, so here we go. I guess that froze with that on there. Yay. All right, so it says the limit as x approaches 2 of this guy does not exist. Now, I'm telling you, this is wrong. This is not the right answer. So what is wrong about it? Well, You know, guys, this is 1 over x squared is this little graph, right? And so this is that moved over to 2. All right? And notice that both sides are going to be going in the same direction. And so if they know something about 1 over x squared and they know about translation, they would know that this is just 1 over x squared moved over to 2. So at 2, both sides are going up. So the correct answer is positive infinity. And then I asked them to explain the faulty thinking. And they can say anything that is true. You know, and I said that I worked it wrong, so they can say, you know, Kitty did not give the best answer, did not give the best directional answer, because if both sides are going in the same direction, the directional answer is a better answer than does not exist, because positive infinity means I do not have a limit, but this is the direction that both sides of the function are going in. So here's number 40, and here's your problem. This is not correct. And so if you plug 0 in, you get cosine of 0 over 0, which is 1 over 0, which means it does not exist because there's a vertical asymptote there. So there's a vertical asymptote there, and they thought, and there's a vertical asymptote, and Kitty used the sine rule. Thought this was a special rule, like sine, or something to this effect. Now, how did I know that there was an asymptote here and there wasn't a directional answer? If you know things about odd and even functions, cosine is even, and 3x is odd, and an even over an odd makes an odd function. And if it's odd, then it's going to have origin symmetry, which means they cannot go in the same direction. They have to be even, go in the same direction. So that's one of those things that I encourage you to talk about symmetry because it helps you figure things like that out. Let's look at a few more problems from the test. Oh, I think there's just one. This is the doozy. So here's the answer. It's 7, because 0 goes to 7. Well, we know that this is a parabola, and somebody took a point out of it. So this is that up parabola that we talked about a minute ago, and at 0, somebody just plucked a point out, right? They just plucked the point out right there. So, and then they put another point up here. But limit-wise, coming in from the left and the right will be whatever the value would be if it were there. So if you plug 0 in, you get 4. So the limit, as x approaches 0, of f of x is 4, not 7. And they gave the f of 0 value instead of the limit value. So I just want to show you, those are kind of some fun things. It also kind of warns kids not to do that, not to go, ooh, the cosine rule doesn't work. You always plug it in first to see what's going on. And it also lets you see it, okay, well, what is a real answer? It's a warning not to do this on the test and for you to get their thinking from them. Well, I hope this helped. This is the last limit video. The next one we will have will be derivative video. So I hope this was helpful. Thanks. Bye-bye.